be talking about using irrigation equipment for frost control, frost protection. So the content of what we're going to be talking about is going to be, we're going to look at the definition of frost, types of frost protection, using irrigation, the theory of it to control frost protection. Sprinkling, 4 types of sprinklers, irrigation and frost protection systems, then we're going to summarize. Just before we start, in terms of climate control, we don't know where we're going with climate control. It's uncertain. I've seen models that suggest that frost events are going to increase in South Africa, and see models that it's going to decrease. We just don't know where we're going. But there is aftermath of frost. So frost is minute ice needles formed at night upon the ground and exposed objects when the dew point is below freezing point. Okay, so when the dew point, that's the temperature at which dew begins to form. Now, just one thing here, we just want to mention that although we say frost protection, there are no guarantees. So frost mitigation is a more appropriate term. So what are the conditions that frost occurs, when it happens? One, we've got to have clear skies at night. Daytime temperature's got to be above 0, and we're getting incoming radiation. Clear sky at night, clear sky at day, clear sky at night. Must be dry, low relative humidity, no wind or light winds, not more than 8 kilometers an hour, and we got outgoing radiation. So when we get these conditions, we get warm air going up, cold air coming down, and that's temperature inversion. The conditions when it doesn't happen. We're not going to get frost when we have cloudy skies at night, because the clouds reflect the energy back and part of the heat returns to the ground. And when we've got, it's moist, it's humid. So then we will have some of the heat will be absorbed by the moisture in the air, and some of the heat's going to get reflected by the moisture and by the carbon dioxide. The types of frost protection. We've got 4 main types of frost protection: heaters, big fans, thermal nets, and water sprinklers. But I'm only going to be talking about, I'm from Netafim, I'm going to be talking about using frost protection equipment that we supply and that we do. So we're going to look at this as the subject of this symposium. Using sprinklers for frost protection. We're going to look at the theory now. Water, or anything, has always got 3 phases. You've got gas, liquid, and solid. For water, we look at the water that we see every day. Is it liquid? When it's a gas, it's water vapor. That's the vapor that we have hanging around in the air. And when it's a solid, it's called ice. Now I'm going to explain latent heat. It's a fancy term, but I'm going to try and make it sound as easy as I can. Water, at the moment that water changes from its liquid form to ice, that's at 0 degrees, not here at sea level. But in order to do that, energy is used. And what actually happens is, when water changes to ice, energy is released into the surroundings, and the surrounding temperature increases. The temperature around that block of ice, or wherever it is, actually increases. And that's called latent heat. Conversely, when we go in the other direction, when we go from water to water vapor, when it evaporates, again, energy is used, but this time, heat is taken from the surroundings. So if the heat is taken from the surroundings, we take away heat, then the temperature is going to go down. This is evaporative cooling. It's what we all know as human beings. We all sweat. That's how you know when you look at a fan, you put the temperature gauge or a thermometer on upstream of this fan and downstream of the fan. The temperature is the same, but you walk under the fan and you're getting cool, because that's evaporative cooling from your sweat. And also farmers who have greenhouses will be familiar with this, because you use evaporative cooling. Just to summarize that there, when these phases move in this direction, the bottom here, okay, from ice to water vapor, the temperature decreases. The temperature surrounding the water decreases. And in this direction, when we go from vapor to water and water to ice, the surrounding temperature increases. And that is the essence of, of using water to control frost. One thing here, though, the temperature effect of water to vapor is stronger than from water to ice. Okay? This process here is stronger than this here. And the reason I'm showing this is because it's going to be late. We're going to look at this a little bit later, but effectively what actually happens is the energy involved in this process is 7 times greater than the energy involved in this process. So when we use latent heat for warming the plant's surroundings, we sprinkle water, and we sprinkle water onto the plant, goes from liquid to frost, okay? And there is an apple bud, so you've got your ice forming. And it's the formation, the ice formation, that increases the temperature of the surroundings, not the ice. The ice itself doesn't protect the plant. It's the actual formation of the ice. So as long as water is continually sprinkled onto the ice and ice keeps forming, the plant temperature will always be above 0. If we stop, and we stop the ice formation, we just leave it ice, that won't happen. We've got to keep watering the whole time. If water is stopped, the coat of ice by itself will not keep the temperature of the plant above 0. And remember, I just mentioned now, when we go in the other direction, that it can be 7 times worse. That can actually happen. It may even revert or melt back to water and vapor, and causing a strong temperature decrease, because we're now already below, the ambient temperature is already below 0, and now we're going to go even further below 0. So that's why we cannot afford to stop. Once we've started, we've got to keep going. Just a bit of terminology here, in millimeters an hour. If you take 1 liter, a jug of water, and you pour it onto a tray that's 1 meter by 1 meter, that will be 1 millimeter deep. So if we pour that onto a tray and it takes us 1 hour to do it, that's what we mean by 1 millimeter per hour. Then going a little bit bigger here, another terminology which we're going to use just now, is called cubic meters per hour per hectare. If we just take 10 cubic meters on 1 hectare, okay, so if we take that 10,000 liter, 10 cubic meters, 10,000 liters, the same, in that like JoJo tank, and empty that onto 1 hectare, 100 meters by 100 meters, it will be 1 millimeter deep. So now, when we want to warm the plant surroundings using sprinkler equipment, water must be continually sprinkled onto the plant, keeping the ice wet. Ice formation must be continuous. And if the air temperature, the ambient air temperature, does not drop below -5, a rate of 3 millimeters per hour will keep the plant's temperature above 0. So when we design a system, we will design this for putting 3 millimeters per hour, and it's a lot. Because you can imagine your evapotranspiration, your crop water loss per day in apples varies between 3 to 6 millimeters a day. Yeah, we're talking 3 millimeters an hour, so it's very, very fast. We've got 4 types of sprinklers. These are mainly based on the diameter of throw. We have full coverage, localized coverage, high efficiency circle, and high efficiency strip. Now, taking a normal orchard spacing that you will be looking at, where we have a row spacing of 3 meters and spacing between the trees of 1 meter, and the canopy width is 1.2 meters. Now, to this, we're now going to apply this 3 millimeters an hour. Now, if we've got full coverage, we're using a mega net. That's not important right now, but the spacing would normally for this product would be 10 meters by 10 meters. So we're going to be putting onto our orchard with 9 meter spacing. So instead of, we're going to have 10 meters in that direction and 9 meters in this direction. But when we do this, it wets 100% of the area, okay, including here between the rows. Now, we don't really worry about frost there. We're only worrying about the canopy. So this one uses a lot of water, but it doesn't use many sprinklers. Then we have a product like this, which is localized coverage, where we'll use a sprinkler like this, and we'll use more of them. It's more efficient. Putting on the same application rate, it will use less flow rate per hectare. That's where I showed you just now, about the cubic meters per hour per hectare. Then what we can do if we just take a normal sprinkler, we're going to, this would be just a normal sprinkler like this. Now if I take this sprinkler, the lowest we can get this sprinkler to, the lowest flow rate that we can get this sprinkler down to is 27 litres an hour. Call it 30 litres an hour. Now what we can do is we can put it on a device like this, and we insert it on this, and it considerably increases the cost. Just to give you an example, that's about R5.50 and this is 105 Rand. So this, it does increase the cost quite a bit, but it can be worth it, as I'll show you later. But what this does, if I bring the flow rate of this sprinkler by itself down below 27 litres an hour, it won't work. Instead of throwing over there, it'll just throw down here somewhere. Okay. Well, what this device does is there's inside here, there's like a little pop suck, and but the pop suck's full of air, and it will squeeze itself when the pressure builds up, and then it'll spurt it out. So it'll pulse. So every time it pulses a lot of water, but it only just goes, and by that way, we can come down to a lower flow rate below 27 litres an hour. So that's what it looks like here. And you'll see now the way it's pulsing. On, off, on, off, on, off. So when we put this on an orchard, we will now come down to 3 metre by 3 metre spacing, okay? But it's more efficient than the previous ones that we showed you. Now what we can go one step further. When we go one step further, this thing here produces a circle. What we can do is we can change it, and we'll put this device on it. This device doesn't create a circle. This device creates an oblong shape, a rectangular shape, which suits our orchard a lot better, and we use even less water. So there it is there, and there is our 1.2 metre strip, and those colours there, that's coming from the different jets. But all it just means is it just wets a strip like that. It doesn't wet outside the strip. So I'll just show you what that looks like on an orchard. You'll see the water entering this from the bottom. Now the pulses start. 1.2 meters width. So when we put this onto the orchard now we can open up this spacing here to 5 meters, okay? And what it's doing is it's just wetting the strip, but we're not wetting in here. We're not wetting where we don't need the water. When we now look at putting all 4 of them together and summarizing them, I've explained about the spacing, but what it means is with the full coverage, we've got 111 sprinklers on a hectare. We go to the more efficient one like that, and we've got 6 times more sprinklers per hectare. Then we go to the very, very efficient one. Now we're going up to 10 times that. And then when we go to that strip next, we come back down to this level here. Now what the effect of that is on our flow rate. Our flow rate, the flow rate now, that's the size of your pump and the size of your main lines. In the full coverage, we're pumping 39 cubic meters an hour, cubic meters an hour per hectare. When we get to a more efficient one, we come down to 33, but now we start halving it now, down to, when we use that one higher, the circle high efficient one, then it's 22, and then we're coming down to this 20 is half of using that strip one. So although it's more expensive, the actual devices themselves, the actual irrigation system, your pump and your pipes are going to be less. Now if we just look at this in irrigation terms, okay, the frost protection full coverage, just working on approximately 5 frost events a year, you're going to need to store, in order to we're going to be pumping 400 cubic meters an hour. Your pump size just approximately is going to be 110 kilowatt, your motor size that drives the pump. And we're going to be using about 20,000 cubic meters storage. When we go to the high efficiency, we've got half the flow rate, okay, half the kilowatts, half the power, and half the storage. And then just compare that to an irrigation system. An irrigation system, remember I said we're only using 3 to 6 millimeters a day. So the flow rate comes right down in an irrigation system, and for a 10 hectare system, we'd only be using 11 kilowatts, but then we have to store all that. That's a figure for, here in Bethlehem, you're using approximately 640 millimeters a year. So this is just for comparison purposes only. This is not I'm not going to give you a quote, but this is just to put it into some things into perspective. Is that a frost protection system that I've shown you just now is in the region of 100 to 120,000 rand a hectare, compared to your drip irrigation system, a micro irrigation system, whether it be micro or drip, of around about half of that, 45 to 55,000. But these are just approximations only. So just to summarize, just mentioning that you can also use this as in a heat wave. And just some misconceptions. The coat of ice by itself, as I just mentioned, is not a jacket that protects the plant. This is not a jacket that protects the plant. And if it begins to melt, more damage than if it were not there can happen. Okay? So if you cannot achieve that 3 millimeters an hour, it would be better not to do it at all, because you could end up where the ice is not being formed fast enough. Then the pulsing of the sprinklers, this pulsing that I see, when people first see it, they kind of think it's something to do with frost protection. It's got nothing to do with frost protection. All it is just to mention, instead of the water just landing over here, we get it to land over there. That's the only reason that we use it. It's just used as a means to traject a low flow of water further than it would without the pulse. Success stories. Here are trees in the Western Cape, coated in ice, and this one's in Denmark. This one's actually using that strip. This is full coverage in the Western Cape. So, just to summarize, for frost we need clear skies, low relative humidity. We need to turn water to ice. But the thing that protects the crop is the latent heat, and we have to achieve that by continuously applying 3 millimeters an hour, and that will keep the plant temperature above 0 degrees. And for that we use sprinklers, where we use full coverage, but that will have a high flow rate, or we have high efficiency, where we will have a lower flow rate. Thank you very much. Thank you.